So what is differ? When you go back to the traditional try-catch based exception handling, there is a try block, there is a catch block, and then there is also a finally block. Whether there is no error or whether there is error, whether or not there is error, there is a block that gets executed 100%, which is a finally block. Okay, so finally block is used generally to clear all the resources, any external resources or any file descriptors or network IO socket descriptors, socket IO connections, database connections. You want to close it. Generally, we use the finally block in order to close those things, in order to clear the resources or clean the resources, whatever you call. Okay, I can't say exactly the same thing, but there is something in Go which is called differ. Okay, differ, what it does is, differ is a keyword basically. That keyword should be, that keyboard can be used to execute any function or a method, whether it could be an anonymous function or it's a named function. It is used to execute, but what kind of execution? It's a deferred execution. Defer defers the execution towards the end of the call stack. So defer defers the execution to the end of the call stack. What do I mean by here is, let's say I create a function, anonymous function. Let me put it as print line. Print line end of main, and here I write it as, for example, start of main. This is a sequential execution. When you execute it, in fact, you don't need this. You can directly call this as well. Of course, you don't need this. So there are two function calls. So start of main and end of main. Who is the caller of print line? Main is the caller. Who is the caller of this one? Again, main is the caller. This is a sequential execution. So what differ does is, if you if you put this particular line of code over here, and then you know that this gets executed first and this gets executed next. When you put the differ in front of this particular functional call, because of differ, the function gets executed before going to wrap its caller. Who is the caller? Main is the caller. What kind of function it is? It's a function, but it is a deferred function. So what does it mean? Differ differs the execution to the end of its caller. This execution is deferred. That means when I execute this, start of main gets executed at the beginning and the end of main and is executed towards the end, even though the order of function calls are, the end of main is at the towards the beginning and the start of main is the next one, because of deferred function. The basic behavior of this differ is that. Okay, so what gets deferred? Let's say I put another differ print line. Okay, end of main, maybe 2, end of main 1, let's say. So all the differ calls for this particular caller, caller is main is calling these two functions. All the differs, there are two differs directly in the main. All these differs are inside the call stack, inside the stack. All differ calls are stored in the stack for a functional stack frame, for a caller stack frame. Here the caller is main. There are two differs. So the first differ gets into the stack and then the next differ gets into the stack. That means you know the stack first in last out. That means what gets into the first? This one. Let's assume it is 1 and this is 2. 1 gets into the stack and then on top of the 2 comes on top of 1. So when the caller is going to uh, the caller is going to exit, the caller is going to coming to an end, then it goes to its deferred call stack and then it executes. Then what gets executed at first? Okay, last in first out. Whatever is inserted towards the last end is gets executed to the first. So end of main gets executed at the first, and then on after that end of main one gets executed. So all the calls inside the differ are executed in that particular order, last in first out, for a particular call stack. Okay, we are talking about main here. Fine. Let me go and then do something else. I create a function which is a normal function. Okay, and I put a differ. Again, I create a function. Here I got to write it as print line hello world. If you look at it, so assume that this is function 1.1, assume that this is function 1.2. Okay. If you look at this particular function, the third differ, assume that this is the third differ. The third differ is the caller of the third differ is not main. The caller of the third differ is function 1.1. So this is not maintained with along with this differs. That means if I execute it, this is not maintained on this particular call stack. So this is maintained separately for this particular function 1.1. Let's say if I say differ print line end of function 1.2, maybe 1.1, and start of function 1.1. So there are a couple of things we have to discuss over here. So this differ 1 and differ 2, okay, differ 4. There are 4 differs altogether, but there is some difference between these differs. Differ 1 and 2 belongs to main stack. Differ 3 and 4 they don't belong to main because its caller is not main. The caller of differ 3 and 4 is not main. The caller of differ 3 and 4 is function 1.1. So what happened? These differs are executed with respect to function 1.1. That means, so it goes here. So this is not, gets into the call stack. This gets into the call stack, not the call stack. This gets into the deferred stack. This gets into the deferred stack, and then it goes to 7. Sync 7 is a separate function, so separate call stack frame is maintained. and then I said differ. For this particular functional stack frame, this deferred is inserted into the stack, and then this deferred is inserted into the stack, and it is there, and then it comes to an end of the function. That means what defer is executed with respect to this function, this gets executed at the top, then this gets executed after that. Sorry, this gets executed at first, and then this gets executed, and this gets executed. After that, this gets executed, and then this gets executed, and this gets executed at the towards the end. So start of function 1.1, because which is not a deferred one. This is a sequential execution. It comes here, defer, defer, and then this is here. End of function 1, because with respect to this function is completely wrapping up before unwinding this function. Okay, then before unwinding this function, then it looks for are there any differs. Before going to exit this function, it looks for, it checks whether, it checks means, it means the runtime checks whether are there any differs. Yes, there are differs. Okay, call the differ, and then call the differ, then execute the next function, and then going to unwind this function called main, going to exit main. Before going to exit main, it looks for are there any differs. Yes, there are two differs. So execute this differ and then this differ. This is a process everywhere. I mean, it's not confined to one differ or two differs. Any number of differs are there, then this is the process. Let me put it as this as a differ. That means there are three differs, then this got to be the third differ, this got to be the fourth, and this got to be the fifth. In fact, these are not fourth and fifth, these are one and two with respect to this function. But however, assume that we have five differs. Technically, differ 4 and differ 5 or differs for the function at function 1.1. Those are not directly, not differs for main. Fine. When you look at this particular code, this is an anonymous function, this is an anonymous function, this is a normal function. However, it doesn't matter whether it is an anonymous function or a normal function, it's a function. Basically, it is a function. Okay. Now there is a differ called line number 4. There is a differ at line number 5, and there is a differ at line number 7, and it jumps to line number 14. First, this gets executed. After this gets executed, then all rest of them all are differs. So the last differ would be executed. So this got to be the last differ. So it starts executing this function. It gets into the function. Then inside the function, that means inside executing, while executing this function, still there are two differs. So this gets executed at first, and then this differ, and then this differ, and then this differ, and towards the end this differ gets executed. Start of main, start of function 1.1, end of function 1.1, hello world, because this is also differ, end of main 2, and then end of main 1. That's how all the differ calls gets executed. That is how all the differ calls gets executed. The order is very important. So whenever you are talking about differ, two things we need to keep in our mind. Number one, the who is the caller of the differ? Here, for these three differs, the caller is main. But for these two differs, the caller is not main. The caller is function 1.1. So the stack is maintained with respect to its caller, not with respect to there is no single stack is maintained. All differs as the numbers I gave 1, 2, 3, 4, 5. Actually, it's not 5, 4, 3, 2, 1. It's not like that. It's the differs are based on its color. Let's say I put over here. Here the concept is different. First line number goes into the stack, line number 5 into the stack, and then it found out that line number 5 is another function. So a separate function stack frame is created. Again, inside that there is a stack, it gets inside, this gets inside. Okay, and all. These are all these are all kept in the stack. Then it goes to line number 12. It is put on top of two differs because that is the last one with respect to main, and then line number 13. So this gets executed first, this gets executed to the next, then it goes inside, this gets executed first, then this, and then this. End of main 2, start of function 1, end of function 1, hello world, and end of function 1. This is how the differ gets executed. Okay, that is what basically how differ work. Okay, next. Let me write another example. Let's put string is hello world, and then I create a variable uh, index comma value range of str1. I put print line of string of v. V is a room, so you're typecasting it as string. So each character is printed in a separate line. Let me put it as a same line. And here, this you know what would happen, but I would like to put it as a differ. So with respect to line number 7, there is a block. A call stack is created for the block, and then here it goes. You are calling a function as a deferred function. That means all the functions you are calling a function called print line to print a value. But these are all deferred functions. So what happened? First of all the functions are inside the stack. Okay, VH gets into the stack. The function call, not only the variable, the function call gets into the stack like that. 1 2 3 4 5 6 7 8 9 10 11 11 times all the functions gets into the stack. The moment it goes out of the scope, everything gets popped out. So you could see that all the variables are called in a reverse way. All the way it printed all the variables, all the values, sorry, of an iteration in a reverse order. The reason is all these functions are executed before going to be an end of this particular block, and that's what it gets executed. So you could see that all of them are in reverse way. Okay, fine. Let me go through the another example. Just would like to give you the some idea. Let me create a variable called a. Maybe I give as 100. I put differ function of print line a, maybe value of a in differ, then I put a plus equal to 1, and then I print line value of a, uh, value of a. So this is pretty tricky part, and this one you understand. I hope you understand. This is the tricky part. I create a variable called a equal to 100. So if you really look at it, a is a global variable with respect to function 1.1. It's a closure. We can call it as a closure because it's going to use global variables. Now, so it goes here. Don't worry about this. This you understand. As I'm starting from here right now, the value of a is 100, and then I go here. I say defer. So that means whatever I got to execute over, it got to execute over here. It is deferred so that it would be executed towards the end, and a plus equal to 1 and print line value of a. The value of a has become 101 and printing the value. The value of a is already has become 101 and then printing the value. After that, this gets executed. Okay, if you really look at it, the value of a is 101. The value of a in differ is also 101, and then these differs are printed. You know that one thing you need to understand over here is since there is a block over here, these differs are executed with respect to main stack frame. Okay, just not just a block, so that it has not created a separate stack frame for these differs. If you create a function, it's a different thing. Let's say I create a function over here, and then I got to execute a function. It's a different thing because the moment it is a function, it's a separate stack frame. So my function is executed at first, but how the function is executed? Again, deferred execution because it's a separate function. It has got its own differs. But if you don't use it as a function, these differs are executed. These differs are stored in the stack along with these other differs. Fine. That is not the actual thing I would like to explain over here. So the value of a is a global variable. So the global variable is being used. This is how the differ work. What if I want to have the separate copy of A rather than even though the execution should be deferred, let me put it as a variable called B. I put it as B plus equal to 1. Okay, a value of A and B, and value in defer A and B. I just would like to give two variables I have created and all. So now what I do is the value of B I pass over here. I didn't pass for A so that I can show the difference. The value of B is passed over here. Then exactly what happened is because I passed the value of B over here, the value of B copied to this particular function. That means 200 is copied over here. A separate copy of B is copied. It's a copy because it's a normal variable, right? It's not a reference. It's a copy. So B is not a global variable no, here. Let me put it as, sorry, put it as B1. So the value of B is copied to B1 and then that's what you're printing. So even though you increment B1, it would not affect this one because the separate copy is maintained. Before going to increment, before going to perform the arithmetic operation, the separate copy of B is maintained within this function. But A is still a global variable. You see that the value of B, A and B, let me put A and A comma B, the value of A comma B here 101 and the B is only 200, whereas the A is 101. The reason is A is a global variable and B is a local, B is copied to a local variable within the function. So whatever happens to B, it would not impact the B within the function. So this is how the variables, how do they react, how do they work within with the differ. Okay. So just to summarize, differ defers the execution to the end of the caller. That means if the caller is main, end of main, the caller is something else like function 1.1. So that the differ is with respect to its caller. All the differs are called differ is called 100% unless until it's a fatal. I will explain about fatal. Fatal means your application is completely crashed. You don't expect differ, but normally for panic is a kind of an error. Next concept I would like to explain. Even during panic, differs are called. Okay, when there is a panic, even there is a panic, a defer is called. All deferred executions are called before going to be panicked. So defer is something like a not a final block, but you can think of it. It is 100% executed. It is 100% executed. Okay, this is what the defer.